A module is actually just a Python file containing Python functions, variables, or classes. Of course, these functions and other data types inside a module are not randomly grouped inside that file. They are grouped together to provide some functionality which can then be used further inside other programs. Modules are also a great way to logically organize your code. There are a lot of Python modules you can use into your programs. Some are built-in, remember the sys module, and some can be downloaded, unzipped, and installed, like the ones you can find in the Python modules directory on this virtual machine. You can also create your own modules, meaning you can write some code into a file and then use that code in the application you are building by simply importing the file. Now let's consider the math module, which is a Python built-in module, and see its contents in the Python interpreter shell. So let's go in the shell, and first let's import math, and then do a dir on math to see its contents. We can see here a list of names which are specific to this particular module and exist within its own namespace. Now remember the way we used the argv function from the sys module? After importing the module, we typed the module name, so sys, then a dot, and then the function name, argv. This is the general rule for accessing module functions and variables when using the import statement. Now we can do the same with the math module. So let's access the value of pi. So math.pi. Okay, so this is the pi number used in math. Nice. If you forget to import the module you need and try to access one of its variables or functions, you will get a name error saying that the name math is not defined. Now let's create our own module and see the three ways in which you can import data from a module. First, let's exit the interpreter. We are currently in the working directory. Let's create two files here. So touch my module.py and python app.py. Let's consider my module.py as being our user-defined module and python app.py as being an application we are working on. Let's open each file in a separate terminal so we can see this better. So vim my module, and over here let's do a vim python app.py. Okay. In our python app.py file, we are going to enter just a print statement. This will be a very basic Python application. So let's say I for insert, print, this is my app. Okay. Let's save it and run it. So Python. Okay. Now let's also enter some code inside our module. We will define a variable, a function, and a print statement here. So let's go over here, I for insert. Let's say my var equals 10. Let's define the function. So def my function without any parameters. Inside the function, let's enter a print statement. So print, this is the function inside the module. Okay, and then another print statement outside the function, print, let's say this will be executed. As you can see, the myvar variable is not used anywhere in the module, and the function is not called anywhere either. They are available there for you to import and use them into your program. Let's save the module now and see how can we use the code inside the module into our own application. As we've seen so far, we can use the import statement in order to use the code inside the module. An important thing to remember here is that when you import a module into your program, Python will execute the code inside that module. This will happen only once, no matter how many times you import that module. So let's test this by importing my module into Python app.py. So import my module. Both files are in the same directory, so the module is automatically found by our application. When importing a module, you should skip the .py extension, so just import my module. Let's save this and run it. Okay, as I said, when first importing a module, the code within that module is executed. So now we got back the string printed by the module and then the string printed by our application. Cool. Now to prove that the code in the module is executed just once, let's say that for some reason you import that module twice into your application. So let's go ahead and enter another import statement into our python app.py file. So let's say import my module. This is a very basic test. This is not something very used in practice. Okay, now let's run the app again. So here we have the proof, the string printed by the module. Let's also see the code inside the module. So the print statement inside the module is executed just once, even though we have imported the module twice. So this will be executed is displayed only once when running the app. Okay, nice. Another thing to add here is that now you have all the variables and functions inside my module available into your program's namespace. You can reference them and use them by typing the module name, a dot, and then the variable or function name. So let's test this. Let's go into the file. Let's go ahead and delete one of the import statements. Okay. Now let's go ahead and print my module dot myvar, and also let's call the function within the module. So let's say my module dot and now the function name, so my function. Okay, let's go ahead and save this, then run it. Okay, as you can see, both the value of my var and the print statement inside the function were executed when running the python app.py file, because we referenced them correctly into this file. Cool. Now this was the first way of importing code from an external source, a module. Let's see the second way. You can use the from import statement to import only some variables or functions from a module into your application's namespace, thus reducing the resource usage of your program. Okay, let's say that from my module you only need to use the myvar variable into your application. You can do this in the following way. Let's go into the file and replace the import statement with, sorry, I keep forgetting, I for insert. Okay, so from my module import, and we said that we need only the myvar variable, so import myvar. Okay, let's go ahead and delete this, and also let's delete the reference to the module. Now let's run our app one more time. This time we got the string printed by the module because Python executed the code inside the module, so we got this will be executed. Then we got the string printed by our application, so this is my app, and then the value of my var, which we have imported. Notice one more thing here. Unlike the first way of importing we've seen earlier, when using the from import method, you are not required to specify the module name before the variable or function name. Let's see the file one more time. So as you can see, we didn't need to specify my module and a dot before printing my var, so before the my var variable. Using the from import methods, you can use any variable or function directly into your program without specifying the module name. So remember this. This is one advantage of this method. On the other hand, you cannot create another variable with the same name into your application, so you cannot define another myvar in the current namespace of Python app.py. The last method of importing is using the from import and a star or an asterisk. Here the star means import all names in that module. This method is generally not recommended because it overloads the local namespace of the application you are importing into. So if you want to import all the names in a module, you should better use the old import statement. Now that we've seen the import methods, let's talk a bit about where you can store and how you can locate a module into your file system. In our example, we had both the module and the application file in the same directory. So if we do an ls on working dir, you can see my module and python app.py inside the same directory. Well, Python first checks the current directory to see if the module you are trying to import is stored there. If it isn't in the same directory, Python will look for the module in all directories in the Python path variable, which is actually a list of directories. You can set the Python path variable with the following command. Let's say set Python path equal, and then the path you want to configure. Let's say in user local lib Python 2.7 and so on. Finally, if Python does not find the module until this point, it will search into the default path, which is usually this one over here, user local lib Python 2.7. This is the case for Linux, of course. The last thing we are going to talk about in this lecture is how to skip the execution of some codes when importing a module. In our module file, let's say that we don't want to execute the print statement at the end of the file, so print this will be executed. So we don't want this print statement executed when importing the module into our application. We want to keep it in the module, just not execute it when importing that module. For this, we are going to use a trick in the module. So let's get inside the module. I for insert. We are going to include the code we don't want to be executed at import using an if statement. I will write this and then I will translate it. So, let's get down here. If double underscore name double underscore equals double underscore main double underscore colon, and then the code you want to not be executed when importing the module. Okay, let's save it. Let's see it. Okay, let's go ahead and delete this. Now in our application file, let's return to the old import statement and add the module name as a prefix to my var and my function. So let's just import my module, print my module dot my var, and let's call the function inside the module. So my module dot my underscore function, and let's save the file. Now returning to our module, the if statement can be translated like this. If this file, mymodule.py, is executed as the main program, let's say as a standalone application, go ahead and execute the code below, in addition to the rest of the code in the module. If the file isn't executed as a main program, but instead it is used as a module and imported somewhere else, then don't execute the code below the if statement. So let's test this. Let's execute our application. Notice that the print statement below if in the module is not executed anymore when we import the module. Now let's run the module as a standalone application and see if the print statement gets executed. So Python mymodule.py, and indeed we have the print statement printing the string as expected. This is because this time the file was treated as a main program and not as a module. To find out more about the theory behind this trick, check out the link in the additional resources section of this lecture. For now, just remember the trick itself. You can apply it whenever you build your own modules.